Hello, AS Math. Sorry, I'm a little giggly right now because I'm hiding something from you guys, and you'll see in a little bit. But it's Mr. Knight again, lesson 6. This time we're going to look at simultaneous equations. So we tend to solve equations just by themselves, isolate the variable and then find out what it is. But sometimes you could do that with two equations at the same time, and that's what we're going to do. So we're going to take this one big example. Okay, we're going to be farmers today, and go to a poultry farm and actually use 3 of these methods: elimination, substitution, and graphical method, in order to solve the simultaneous equation we're about to get. And then we'll look at one nonlinear example, which you'll see what that is in a little bit. So I'm hiding this because of the example. It has to do with it, but I'm actually like really embarrassed by it. So let's look at the example and you'll know what I mean. At a poultry farm, 6 hens and 1 duck costs $40, while 4 hens and 3 ducks cost $36. What's the cost of each bird type? So we're going to first start out with elimination, and we're going to try and solve this bad boy. So what I'm hiding from you guys is I tried to draw a chicken, and let's just see what it looks like. Chicken. Okay, now that you're done laughing at me, and rightfully so, let's please move on with the problem, okay? That was my, look, I even tried to shade it and like be all fancy with it. Look, I'm so glad I'm a math teacher, not an art teacher. Okay. Alright, on this poultry farm, 6 hens and 1 duck cost $40. So we need to establish some variables, okay? Let's call H our hens, and then our ducks will be D, okay? And so we know that 6 hens, so 6H, and a duck, plus a duck, that's going to equal $40. And with this hens and ducks, see, I drew a chicken. What am I doing? We're not even talking about that. Is that a hen or a chicken or, I don't know. Anyway, this is not really just hens and ducks. This is the cost of hens, and this is the cost of ducks, okay? Whatever that might be, okay? So we need to figure out what that is with the second equation as well. We also know that 4 hens and 3 ducks is going to equal $36. Now you don't really need the dollar sign because it's already embedded in the variables themselves, so let's just work with that. Elimination's idea is basically figuring out how to eliminate one of our variables, solve for the other one, and then use that knowledge to get the other one in turn. So just by looking at this, we can actually multiply, and you've seen this with our quadratic equations, we can actually multiply an entire equation by something and change it up. As long as we do it to both sides of the equation, balance it out, it should work out, okay? So let's find our first victim. Our victim is looking like D. D is going to be a good victim because I can multiply this top one, the entire thing, by -3, and then when we add and subtract them, the D's are going to cancel. So if I multiply this entire thing by -3, let's see what we get. I get -18H minus 3D equals -120. Okay? And now here, I'm still going to be left with 4H plus 3D equals 36. And now, with them kind of on top of each other, I could treat this like an addition-subtraction problem. These guys are going to cancel. See you later. And we're going to get -14H equals, well, 120, -120 plus 36. That should be 84. 84. Let's double check. Probably right, but I want to make absolute sure. -84. Awesome. Okay. And then we just have to divide both sides by -14, and then I end up getting H equals probably 6, but let's double check. I get H equals 6. So 1 hen is $6. which is $6 more than this. Okay, so that's awesome. So we got 6. Now with that, what I can do is I can actually plug it in to one of my equations and solve for what the cost of a duck would be. So let's plug it into the second equation. Why not? So I'm going to do 4 times h, which is 6. So that's 24 plus 3d equals 36. I subtract the 24 over to both sides. I get 3d equals 12. And now divide both sides by 3. d is going to equal 4. Okay? And it's technically $4, so you can put that if you want. And now let's go to substitution. Let's try a different method. Let's see if we get the same thing also, so we can get away from this horrifying thing that you guys have to watch. That's better. Okay. So, method 2, substitution. We're going to take our same 2 equations we had. I'm going to look at it. We had 6h plus d equals 40. And we also had 4h plus 3d equals 36. Feel free to make fun of my drawing as much as possible. Although I think I'm doing a good job making fun of it myself. So, there's nothing you can do to hurt me, okay? So, with substitution, it's kind of a similar idea. You want to look for a way to rearrange one of the equations so you can isolate a variable. Then you're going to take whatever you get for that variable and plug it into the other equation. So our victim, once again, is going to be d. So d, if I rearrange this top equation, I subtract the 6h over from both sides, I'm going to get d equals 40 minus 6h. Now with this d, I can just plug it in here to the second equation, and now I'll have one equation all in terms of h, which is exactly what we want. So I'm going to get 4h plus 3 times 40 minus 6h, and that's going to equal 36. Let's distribute the 3. So I get 4h plus 120 minus 18h equals 36. Combine the h's, okay? 4 minus 18h is negative 14h. I move the 120 over. Again, I'm going to get negative 84. And hey, look at that. That's pretty much what we got last time. It's exactly what we got last time. H is going to equal $6 again. So now, once again, I can take the other equation. Let's take 6h plus d equals 40. Let's show that one some love. And let's plug this h in for that. So now I get 6 times 6, 36, plus d equals 40. And now I move the 36 over. I get d equals $4. Sweet. Is that what we got in the last one? That's exactly what we got in the last one. Okay. So which method would have been the best to use here? Honestly, I guess in this case you could make an argument for either one. I prefer the substitution method in this case, but that's the cool thing about this is you can actually pick and choose which one you want to use, and if one doesn't work, you can try the other method. Okay. Now let's look at the graphical method. These are both linear equations, so they should actually work if we're graphing them. They should intersect. Okay. So basically, we're going to look for where the graphs intersect. And we're going to actually look at Desmos. So let's take a trip to Desmos. Okay, I have to admit, I actually tried to draw this one right here, and I freehanded it. Let's just move on. Okay, I'm done with the chicken or whatever that monstrosity is. Oh god, that's going to be in your nightmares. So we're going to plug these guys in. We got 6h plus d equals 40. Okay, that's one of our equations. And the other one is going to be 4h plus 3d equals 36. Now, 36. Now, if you're looking at this, I'm getting like exclamation marks. It's like saying warning. That is because Desmos does not recognize h and d. They are really good with x and y. So let's call our h our x, and let's call our d our y. And that should do it. There it is. It shows up. H is x, d is y. Nice. Now they're both graphed, and let's see where they intersect. They intersect here, 6, 4. Hey, that's what we got. We got for our h, our x value, was 6, that's the cost of a hen, and then 4 for our y value, our d value, that's the cost of a duck. So it works out that way too. The reason I'm showing you on Desmos is because if you tried to do this by hand, you could do it. It's just, well, it's just a pain in the butt, okay, if I'm being honest. So use Desmos if you can, but I really like the other two methods the most, but I wanted to show you how all three can work together, okay? So nice. Let's move on from the hens and ducks. I think we've had enough with poultry farms and horrible drawings. Let's move on to something more abstract and mathy, okay? Nonlinear equations. So we are really working with linear equations most of the time. This is an example of a linear equation, the top one. This one is non-linear. Hence, it's not in a line. If I try to put this in Desmos, it's going to look parabolic, kind of like a quadratic equation, whereas this one will look like a line. These work very similar, okay? Probably the best way to do it with this one is honestly to use a substitution method. I'm going to write that down. Use substitution first. That's kind of my biggest tip. And I have one more at the end too. So let's go for this guy, okay? Let's write them down again. Have something to work with. Let's try to solve for, since we're using substitution, let's find our weak link variable. It looks like it's going to be x. So in this case, if I rearrange this, x can equal 7 minus 2y. And now I'm going to plug that in for my x right here. So this is going to become 7 minus 2y. That's going to get squared plus y squared equals 10. And now let's go ahead and distribute this. So I'm going to get, if I'm foiling this guy, it's going to be, and I'm going to actually write it out for you guys, for those of you who want to see it. This is going to be 49. 7 times negative 2y is negative 14y. I do it again, negative 14y, that's negative 28y. And then I get plus 4y squared plus y squared equals 10. Let's combine our like terms. I get 49 minus 28y plus 5y squared equals 10. And now, again, let's move the 10 over. Let's make this look like a quadratic, right? Because that's really what it's starting to look like. So I'm going to rearrange it a little bit because I like my squared term first. Then I got minus 28y. If I move the 10 over, I get 39. So this is plus 39. And then that equals 0. Now from here, we're going to use the slip and slide method. We are going to try to solve for y. So I move this guy over here and multiply. So I'm left with y squared minus 28y plus, well, 40 times 5 is 200, so this must be 195, but let's double check. Yes, it's 195. All right. Now we need to find the factors of 195. I am not going to go through that trouble. I am actually going to find them myself, what they are. Alright, it looks like they get 15 and 13. Let's double check that. 15 and 13, 15 times 13. Cool, yep, I get 195, and they would add and subtract to give me negative 28. So they're both going to be negative, okay? It looks like. So we have 13 and 15. The a value I slid over in the beginning, I'm going to divide both by 5. Alright, let's move this to the side so we can keep it handy. I'm going to continue from the top. I can't reduce this one, so I'm going to take this guy and move it out in front of this. So I get 5y minus 13. This one can reduce to 3, so I just get y minus 3. And now I solve, okay? So I'm going to get 5y minus 13 equals 0. y minus 3 equals 0. So now I'm going to get y equals 3, and I'm going to get y equals 13 over 5. All right. So notice I got 2 answers for my y value. That's okay, because we are dealing with a quadratic, and we're going to see that, let's think about it, if I had a line and a parabola, right, it's going to intersect at 2 different places, right? So you're going to get 2 x values and 2 y values for your coordinates, okay? So we expect that. So what we got to do is we actually have to plug the y in twice, okay, into our linear equation, which was x plus 2y equals 7. So now let's plug the 3 in. So I get x plus 6 equals 7. So x equals 1. That's one of our x values. And then the other one is plugging in 13 over 5. So I get x plus 13 times 2 is 26 over 5 equals 7. I'm going to make the 7 have a denominator of 5, so this will be 35 over 5. I subtract this guy over, x should equal 11 over 5 for my other answer. So we got 4 different answers, but it makes sense in terms of this, okay? Let's graph it on Desmos real quick and just see what we come up with. Let's see it. So we had a x plus 2y equals 7 for one of them, and then we had x squared, whoa, not you, jerk, stealing the thunder, x squared plus y squared equals 10. It's a circle, okay? So in this case, we had 1, 3, that is one of them, and then we also had, well, 1.8 and 2.6. As fractions, we had 13 over 5, that'll be our 2.6, because it was our y value, and our y value here is 2.6. And then 1.8 for x equals 11 over 5. All right, so you can see that we have a lot of different methods of solving linear equations and also solving nonlinear equations by all these methods. So that's your lesson. Have an awesome day, and it's Mr. Knight once again signing out. Eventually. If I can remember where to go. I'm going to keep this in the video. Holy cow, I can't find, where am I? What am I doing? Where am I? What's going on? What is going on? I just want to pause the video, man.